Work it, make it, do it, make sense.
Thanks for coming to this session. So we're going to see together why and how you should consider transforming your REST API into a data streaming API. So quickly to introduce myself, I'm developer relations at StreamData.io. We got a booth, we got nerves, so come and see us. And I'm also the co-leader in France of DevOps for Kids, which is, as you probably know, the coolest initiative in the world. So let's jump into the topic. Modern times. We know that for the last few years, internet has been more and more consumed on mobile devices, finally exceeding desktop consumptions 2.5 years ago, something like that. So we also know that applications that we develop now have to be mobile ready. Even businesses want you to bring your own device movement. The problem with mobile application is that the mobile market is completely packed. It becomes very, very hard when you launch new applications to acquire users, especially active users, and even more to retain them. So we get to make them addict. And we know that to keep our users' interest alive, animation is the key. So that's the reason why I will be using GIF instead of bullet points. I know you are all completely mad of bullet points. I'm sorry. But do you know why animation is so important? Actually, it's coming from evolution. But when I say evolution, it's a little bit older than this. It's coming from this little guy there. Was understood one really important thing. If it moves, it can be two things, food or danger. So in both cases, it might worth worrying a little bit about. And this has created some kind of reflex in our brain, which makes that if it doesn't move, our brain thinks that it's dead, it has no interest, just move away. So on the user interface part of our application, we already know that animation is very important. We already know how to do it. We got CSS3, every mobile framework has its animated component. And even material motion, a very interesting thing to notice is that material motion obviously has a dedicated part to animation. They explain you how to make animation properly. And one of the reasons why they recommend to animate your application is hiding from the user what's going on behind the scene. Because the problem comes with data. When it comes to data, usually we're using a refresh button, which is not the best way to start a happy relationship with our user. That's typically me in front of a refresh button. We know the less interactions the user has to make to retrieve the data he's interested in, and the best it is. And the problem with refresh button is that usually it never comes alone. It always comes with the screen of the dead. And if the screen is staying for too long, the user will be very upset, probably leave the application, and in worst case, never come back. So, repeat after me. Refresh button is evil. We stop using it. Really. That's not me who's saying it's Batman, so if it's Batman, it's true, you know. In fact, what you need is a real-time user experience in your application. So, if you're looking on most popular applications on markets, both in terms of active users or in terms of dwell time, which is the time users spent on your applications, you will notice that it's mostly applications which are based on real-time experience from the beginning, or which has integrated it very quickly. So I took here as example Uber, Twitter, and WhatsApp, but I could have mentioned Slack or Google Drive because it's also the case in our business applications. Because real time has created some kind of new reflex in our brain. Now we got FOMO, the fear of missing out. So those three little dots dancing around are telling me that something is going to happen. You know, something is coming, and I really want to know what. So I'm staying, looking at three little dots dancing to, I don't know why. I mean, absolutely, I have no idea what is coming, but something is coming, and I want to know. I know it doesn't sound really smart after that. I'm sorry. So basically, it's not really complicated to get real time. You just need to take your static API and turn them into a stream of data. Usually, talking about solutions for real time, some are mentions that you probably know, some perhaps not, so I will just check quickly with you. The first one is polling and long polling. Who knows about? Yeah. Webhooks? Who have heard about? Okay, not that much people. It's pretty great. That's going to be interesting. PubSub. WebSockets. So here, obviously, everybody is raising their hand. And server-sent events. Who knows about server-sent events? Okay, great. So we're going to dive a little bit deeper into each of those technologies. But before picking one of them, we have to keep in mind that the solution will depend on two very important things. The first one is your update frequency. Is your data updated every second, every minute, every hour? Are you even able to predict when it will be refreshed or not? Is it completely random? And the second one is the usage of this data. Is it going to be consumed as it comes, and if you're missing one, it's not really important? Or is it the beginning of a workflow? So, let's enter the subject for real. We'll start with polling and long polling. So polling is this, basically. I'm making a request, waiting for the answer, send the same request again, waiting for the answer, and so on and so forth. That's in the fantastic world of theory, you know, where everything is shiny and there is unicorn everywhere and that kind of things. Because in real world, polling quickly turns into polling madness. You will make a lot of useless calls, and you will retrieve the same data a lot of times. I don't know if you're familiar with Zapier. Who don't know about Zapier? Okay, so quickly, Zapier is an application which proposes you to create your own workflow. So basically, you can say, for example, each time I received an email in my Gmail inbox with attachment, save the attachment in my Dropbox account. And so those guys have used polling at first. They've made a lot of bench and noticed that 98.5% of polls were just wasted. And one of the problems with polls is that in case the connection is dropped for any reason, you have absolutely no way to know what you've been missing. So that's the reason why some people have tried to find a solution, and they switched to what we call long polling, which is basically the same, instead, unless that we are going to keep the connection open until the server has new data to send to the client. So yeah, it could work. The problem is, if you're an API provider, very popular, with a lot of calls on your APIs, you will probably not be able having all that connections opened until you have new data to send. So polling is not a solution, long polling neither. It's much more a hack than a real solution, and we should stop using them too. So now let's talk about webhooks. Webhooks, which you can find also under the user-defined HTTP callback name or user post-defined HTTP callback name. It's a concept, a method. There is no specification, so don't look at it. You get a website, which is very useful. That's probably the place where you will find the more information. And there is also a Google group, I think. And they got a very nice logo. And from this point, that's all that we can say for webhooks, because from this point, it's YOLO. Everybody is doing it the way they want. So in theory, again, webhooks work this way. So first, as a consumer, I'm going to send a post request on an API provider saying, OK, I want to subscribe, and this is my callback URL. So you got to provide an URL. Then the API provider will answer and say, OK, subscription created. And each time there is new notifications to send to the client, the server will simply make a post request on your callback URL with data in the payload. OK, pretty nice. But as you can guess, it doesn't work just like that. There is a small to-do list to implement on both sides before using webhooks. So on the consumer side, it means defining callback URL. And this URL has to be accessible from outside. So it means no localhost, not behind the proxy, not behind the firewall. Keep that in mind. For an API provider, first you got to create a subscription endpoint. So it will be two resources. The first one, /webhook, will be used. So the get method is going to retrieve all webhooks available. The post method is going to be used for creating a new subscription. And the /webhook/ID resources, the get is basically the equivalent of classic polling. The put will be used to update our subscription, because perhaps we want to change our callback URL. And the delete method will be there to cancel the subscription. And then comes the very important part for the API provider, because from this point you get to choose how you implement your webhook queue. The first solution, I will not recommend it, but some people are using it. What we call inline HTTP request, basically it means that every time you get a new subscription, so you're going to register it in your database, for example, and then every time you get a new notification to send, you're going to run a cron task, for example, which is going to see every subscription for this notification and which is going to send them manually. So you will have to handle retry, failure, or everything that can go wrong. That's the reason why it's not really recommended. It will delay your answer too much. But it could be, it could work for test, for example, if you're at the beginning of your implementation. The second solution is SQL-based queue. So basically, you're going to store notifications you have to send in your database, and then having the same cron job, which is going to take care of sending notifications to subscribers. So it will not scale a lot, but that's a good solution if you can't add another piece of technology in your stack. That's something happen. The best solution to me is AMQP Broker. So if you already have RabbitMQ or Redis or something like that in your stack, you can reuse it and let him send notifications. The last solution is batch. So batch is more likely to be used when you know that your API will send a lot of notifications. Facebook, for example, they're using a batch. They're sending notifications every 5 seconds, and or if there is more than 1,000 notifications unsent. So now, just to show you a quick example of the setup. So I took here as example GitHub. So it's a repository of mine. You can create webhooks on repository and organizations. So you're going in the settings part, and then you got a webhooks part, and you can add, so payload URL is your callback URL. Then you're going to choose your content type. So in theory, webhooks support both XML and JSON, but remember, YOLO. So. And then you will have to choose which notifications you are interested in. So by default, you will be registered to the push event. You can choose to register to every event that happens on your repository, which is not something I will recommend, more especially if you're on a very popular repository, of course. Or you can select individual events. And then you will receive something like that. So this one is really nice to me because you got a X GitHub event which tell you exactly what has happened, if it's an issue, if it's a pull request, or that kind of things. And in the payload, you get all informations about the event. So now talking about pros and cons of webhooks. So when webhooks arrive, everybody was like, well, real-time updates. Yeah, it's almost real-time updates because as we have seen previously, it will really depend on the implementation you choose for your webhook queue. And if it's a batch, for example, 5 seconds in the world of real-time, it's a very important delay. So it's not real-time updates, it's almost real-time updates, which is really nice. Without dedicated resources, because obviously when we were making polling and even more long polling, we were having often we were having dedicated resources just to take care of this part. We don't need that anymore. That's the good point. Easily consumed. It's a post request, so it's something we already know how to handle. And easily integrated, has everything you need is a server. You probably already got one, so it's fine. But looking at cons, so the user experience is a real problem. I took as example GitHub, which is obviously one of the best user experience you can expect, but that will obviously not be the case for every API provider. And the fact that you have to register, create webhooks, and give your callback URL and other kind of things, it's not a really smooth user experience. Debugging is a nightmare. It's completely asynchronous. So just to be clear, there is company which have based their business on debugging webhooks. Okay? Does not work with all clients. My smartphone, for example, is not really fond of receiving post requests, you know. You just don't care about. So you can't use webhooks with every types of application. And the manual setup could be a problem, because if your API provider is not proposing you to create webhooks through API, you will not be able to automatically create a new webhook. That could be something blocking for your use case. And there is also some known issues. The first one is DDoS attack. So the thing is, on both sides, as a consumer, as an API provider, you will expose resources which are accessible by almost everyone. On the consumer side, it could be used if your callback URL has been cached. It could be used to register you to webhooks you never wanted to subscribe to. And the other case is if the API provider is sending too much notifications that you can handle, you will end it with a DDoS attack. On the API provider side, that's the same problem, because you're also exposing a resource. And we can imagine, for example, especially if there is an API provided to create webhooks, a subscription which will create a new subscription every time the notification is received, and that will obviously end it with a DDoS attack too. The second problem on the consumer side is missed notification. So not every provider are going to look at what's going on once the notification has been sent. Some of them will just send it and, okay, it's your problem. If you received it, fine. If you didn't receive it, I don't care. Some cares about, and in this case, they will expect a response from you. And if you're not providing the good response, then you enter in the other issue, the deduplication problem. The thing is, for example, if, let's imagine that you received a notification, and for any reason, you didn't respond with the expected code, but you still got the notification. Facebook, for example, they will try to send the data again immediately. And then they will continue on until on a decreasing frequency for 24 hours. And at the end of the 24 hours, if your server has not come back to normal and sent the expected answer, the streaming session will just be closed. But on your side, you already got the data. And so you will receive the same data again and again and again until your server sends the correct answer. So you will probably handle with the duplication issues. That's the reason why I quickly wrote this checklist. So on the consumer side, that sounds perhaps a little bit obvious, but keep one callback per webhook. And if possible, make this callback URL as human unreadable as possible. Do not reuse the traditional scheme path of your API. Just make something which is only understandable by computer. Check if there is an expected answer. If your API provider is expecting you to answer with a 200 or other code for when it sends a notification. Be sure that you can handle the request number, obviously. Monitor the payload side. This one can sound a little bit strange, but for example, GitHub, notifications are capped to 5 meg, which means that if the notification GitHub has to send you is more than 5 meg, it just will not be sent, and you will not be notified. So that's very important. And obviously, handle duplicates. On the API provider side, so it's not obviously mandatory, as there is no specification, etc. But implement authentication. That will be the best solution for everyone. So looking at these issues, some people have proposed to just make webhooks a little bit better and move to what we call dynamic subscriptions. On the dynamic subscription, you will find RESTful webhooks. So to be honest, I found these terms a few times, and I've never been able to find more information about this technology, so I think it's just death as it was born, something like that. REST hooks is a solution implemented by Zapier. So if you plan, for example, to propose your API to be integrated with Zapier, you're going to use REST hooks. And one that is more known is PubSub HubHub, which is very nice to say. So that's the one we are going to focus on. PubSub HubHub, which you will also find under the name PubSub or under the name Push. So first of all, it's an open protocol. it's based on the publish-subscribe pattern and on topics. Basically, a topic is just a resource. But it's a term you will find very often when talking about PubSub, so I think it's quite important to know that it's just a resource. It was usually, it was originally designed to handle RSS and Atom feeds, but now we can use it for almost everything we want. And you have this GitHub repository, which is really nice because you will find example in several languages. So PubSub basically, it's an ecosystem of publishers from one side. So most popular are probably Medium, WordPress and Blogger, but CNN is using too. I'm sorry, I was looking for a real news information site, but I only find fake news. Then you get Hub. The most popular is probably Superfeeder, which has been acquired by Medium. But Google App Engine also proposes a hub online, which works really nice. And on the other side of the scope, you will find subscribers. Probably the most well-known are Feedly and Flipboard. Feedly, which we are probably using if you were using Google Reader a long time ago now. So how does it work? To publish content from the publisher's side, it starts with the discovery step. So in this step, yeah, it's not the right code. Sorry. It's okay. Yeah, it's not the right one. So basically, on the header of the application, on the header of the main request or on the main page, the publisher is going to provide two links. The first one is the self link, which basically is, okay, that's me. That's my resource. And the second one is Hub, which is the hub the publisher is going to push data to. Once the publisher has done this step, subscribers will be able to subscribe to the feed. So they will make a post request to the hub. So giving few parameters, I'm in mode subscribe. The topic I'm interested in is this one, and this is my callback URL. And obviously, if it's supported, you can pass a secret. Then the hub is going to make something very important. It's going to verify the intent of subscribers. It's going to check that you're the one you pretend to be and that you really want to subscribe to this publisher. And it's going to send a GET request on your callback URL, passing some parameters. So two we have already seen previously, mode subscribe, topic, and the resource I'm interested in. And the very important thing here is the challenge parameter. So it's a random stream. And another parameter, which is optional, this one, least seconds will give you, if it's provided, the time the streaming session will be opened, alive. And then from this point, the subscribers have to answer the verification request by providing the up challenge in the payload and only the up challenge. If there is also parameters, it will be invalidated. So that's the first step. I took here as example Facebook, because officially, Facebook provides a webhooks API. In fact, when you're looking at implementation, that's the best example I found of PubSub. So, for example, here, we want to create our subscription. And we have to choose between several topics: user, page, permissions, application. Once we've done that, we select fields we are interested in. And then comes a very important part, when we want to publish. So first, the publisher is going to ping the hub, saying, okay, I'm now in mode publish. That's the URL of my updated resource. And then the hub will proceed to the content distribution. So it will make a post request to your callback by giving back two links. The link hub, which is, okay, basically him, the hub, and then the link updated resource as self. And if you previously provided a token, it will be an authenticated content distribution with a signature in form of SHA-1. So it's not very secure, but. And then the subscribers has to pull the updated resource to retrieve the content. And for example, for Facebook, when you receive the notification, you receive something like that. So you are informed of which field has changed, but you are not informed of the content. If you are interested in the content, it's up to you to make a GET request and retrieve it, sorry. And then that's the third big difference with webhooks. We get an unsubscribe process, which is very clear. So the subscribers is going to send an unsubscription request to the hub. It's basically the same as the subscription request we've seen previously, except that the mode is unsubscribe. The hub will check that the intent, that's your intent to unsubscribe, and that everybody is not trying to unsubscribe you on your behalf, by giving a hub challenge too, and then you will still make the same answer verification request, and you're done. So if we are looking back at webhooks pros and cons, okay, we fixed the pro-user experience and we fixed the manual setup, as now everything is done programmatically. But now we got to make another call to retrieve the data. And if we are looking back at known issues, so obviously we fixed the DDoS attack, which is a very nice thing, but you can still have missed notification and deduplication issues, except that this time it will be the hub which will try to send again and again and again instead of being the publishers. So in terms of applications, to me, webhooks are really, really nice if you want to create a workflow. Because basically for both technologies, it's not really the data itself which is interesting you. It's the event. Something has happened and you want to react to it. And so it's definitely what you expect in case of a workflow. So each time, for example, a new issue is open, I would like to create a Jira ticket. Or each time a pull request has been merged, I would like to trigger a Jenkins job. So in this case, webhooks are just perfect. The other case we can think, which really fits webhooks to me, is IoT. Because with IoT, you have absolutely no idea at which frequency your data will be refreshed. You can't predict when your sensor will detect something. But you want to react immediately when something is received. So in this case, webhooks are really nice. PubSub, to be honest, except in case of Feedly and Facebook, I don't really see other use cases. It's really nice because you want to know that something happens. If you don't know it immediately, but in 5 seconds, it's completely okay. And perhaps you're not even interested by the news. I mean, perhaps you will receive the notification and don't care about it, so you will not retrieve it. So it's a really good workflow for this one. So now, let's talk about push technologies. So push technologies, basically two technologies exist, WebSockets and server-sent events. Both are under W3C specification. And as you can see, they appeared around the same period, even if everybody knows about WebSockets and nobody about server-sent events. As you can guess, if they both exist, it's because they are quite different. The main difference is that WebSockets is bidirectional. So both the server and the client will be able to send data to each other. Whereas in server-sent events, it's unidirectional. So only the server can send data to the client. The second big difference is that WebSockets is handling both text and binary. Server-sent events only handle text. Looking at protocols, WebSockets has its own TCP-based protocol. So basically, the handshake will be interpreted by the server as an upgrade request. The server will switch to a binary bidirectional protocol, which does not rely on HTTP anymore, but the server will be able this way to handle both HTTP and WebSocket requests on the same port. Server-sent events on its side, it's normal HTTP. You just have to add this little header you're seeing there, accept text event stream, and it's going to work. As you can guess, having a different protocols means that there is some works to do in configuration. So that's the reason why hops are not really fond of WebSockets. And it's not to bother you. There is a good reason why. So first of all proxy don't handle WebSockets. And for those who knows how to handle WebSocket, there is not that much who handle them properly. It's a real nightmare to configure and to maintain, and that's the reason why hops are really not fond of WebSockets. Server-sent events on its side, it's HTTP, so as long as your proxy accepts long-lived session, it's fine. It's fine. Looking at messages format. In WebSockets, nothing is defined. So it's up to you to define what your message will look like, to define fields in it. In server-sent events, a message is every line of text beginning with the data prefix. So it could be a single line message, it could be 2 lines, it can be a JSON object, everything would work. And the very nice thing is that we got 3 other fields we can use in server-sent events. So the first one is ID, second one is event, and the third one is retry. We're going to talk about them just after, so keep them in mind. Looking at implementation, I took here as example JavaScript implementation on the customer side, but it will be almost the same thing for every languages you would like to use WebSockets and server-sent events with. So in WebSockets, we're going to create a WebSocket object and pass the URL of the API we would like to stream with the WS or WSS prefix as parameter. In server-sent events, we're going to create an event source object. Then you can register to several callbacks. The first one you're probably interested in is on open, especially in WebSockets, because opening the streaming session is made asynchronously. It's prone to error, so you probably want to be sure that the connection is really established before trying to send data from the client to the server, for example. Then we got the on-message callback, so I think this one is pretty clear. As we've seen previously, as there is nothing defined on the WebSocket side, it's up to you to unparse it properly. On server-sent events, you just have to call the data field on your object. And then you get the on-error function, which I will not talk about, because I think this one is pretty clear. The very nice thing here is that server-sent events does not only allow us to listen to messages, we can also listen to arbitrary events. So if you remember this event field you're seeing there, by adding an event type on your message, you will be able to add specific event listeners. Perhaps you're not interested by every types of message the server is going to send. Perhaps you want to make different treatments. That will be very easy to make by giving a type to your message. So we're talking about streaming, so we have to see what will going on if the connection is dropped for any reason. Unfortunately, for WebSockets, nothing is included. There is nothing written in specification, so it's up to you to retrieve, to handle those cases. On server-sent events, we got 2 very nice mechanisms we can combine. The first one is the reconnection timeout. So if the connection is dropped for any reason, the client will automatically try to reconnect after 3 seconds. If this delay doesn't fit your need for any reason, you can change it by adding a retry field that we've seen previously. And once this is done, if you add the good idea to put an ID field on your message, the client will be able to add an header to its request, saying, that's my last ID received, and the server will be able to resend every messages from this ID. So now talking about browser support, which is always the pain point. WebSockets are natively supported by every browser, and that's probably one of the reasons why they are so popular. Server-sent events on its side is supported by by modern web browsers, so obviously not by Internet Explorer. Actually, it's not really a problem, because we can use polyfills, so it means that we are able to handle both connections with Internet Explorer, but also older versions of other browsers. And for Edge, it's under consideration. So on mobile browser support, so it's the same problem for both technologies, only Opera does not support neither WebSockets or server-sent events. So looking at performances side, so these numbers are coming from Mathias Nelson blog post. So Mathias Nelson is the developer of an application called Birdwatch, which basically allows you to navigate in streams of tweets in real time. And so this blog post dates from 2013, but I haven't been able to find other resources, comparing both technologies, and I was looking forward to have external resources, so I'm impartial. So Matthias' use case was to preload 500 tweets at the launch of the Office application. The only technology he knows to make real time was WebSockets, so he made a first implementation with WebSockets, and quickly he was having so many issues opened by users because of WebSockets that he decided to give a try to another technology, to server-sent events. So he makes the implementation and then he makes this benchmark to be sure there were no performance gap. And first of all, he was quite surprised to notice that there was such a difference between the implementation of the same technology in several browsers. And then he quickly noticed that server-sent events was way more useful, way more efficient in his use case, which is normal because it was only text messages. So, as often in programmation, it's not that there is a good or a bad technology. It's just there is a technology for each use case. If you're telling me that you're going to develop a video game or a chat application, obviously go on for WebSockets. That will be the better choice. But in most cases, in our applications, we are interesting to have real times only from the server to the customer, and we are probably only sending text data. So in this case, you will be able to handle data coming from the client by traditional post request, as we're already making for a lot of time, and server-sent events will be way more efficient. So that's the reason why we built StreamData.io, which is a proxy available as a SaaS. So it works with any JSON API. Basically, you're opening a streaming session, and the proxy is going to make the polling for you. At the moment, we only support polling because it's completely transparent for the API provider, but we are working on push connectors. And we will handle everything that can go wrong, so you're covered on this part. You're going to give us any parameters you have, for example, the polling frequency, if you're using query parameters or HTTP headers. And then we will use several features to reduce the amount of data sent. So first of all, obviously, we are going to use server-sent events to send you data. We added a dynamic cache, so it means that if you get customers joining the session between two polls, they don't have to wait until the next poll. They simply can retrieve data from the last one. And the most important probably is incremental updates, which allows us to reduce the amount of data exchange. So let's imagine that on the first poll, we received our snapshot, a big document with 30 fields. On the second poll, nothing has changed. So in this case, we will not send you any notification. If on the third call, only 2 fields of your document has changed, we will use JSON patch to send you only those 2 changes. So to see it more clearly, so JSON patch is a specification which defines a set of operations that could be applied on a JSON document. So you get add, remove, move, etc. And so if we imagine that it is our initial document, and that on the third call, we've seen only 2 fields have changed, you will receive this, which clearly telling you what has changed. And then from this point, you can use JSON patch library to apply those changes to your initial document. So it's much more efficient. Okay, so now let's move to a demo. So I got a drone there, which I would like to make fly on the Bitcoin value. So this is the developer portal. You can create an account for free. And we are going to call it Bitcoin. Oh yeah, obviously, I've been disconnected. So I'm going to create my new application. Going to zoom a little bit. So here a token has been generated. So I'm sure nobody will see the data if it doesn't have the token. I can copy paste any API I would like to test there. Here I'm going to keep this one, which is one of our internal API. It emulates a stock market API. And I'm going to copy paste this command to see what it looks like. So it's simply the URL of the proxy, then the URL of the API, and my token at the end. And here, so I've received my first snapshot of data. And then I received patch, so it's an event of type patch, and in the JSON patch format. The really nice thing there is I can go back to my API section. So my API has been automatically provided by the curl command, but you can create it manually, or you can create it by API. You can duplicate it too. Here I'm just going to change the configuration, change the polling frequency to 1. And if I go back to the terminal, so the polling frequency has been automatically updated without closing and reopening the stream. Okay, nice. So now let's see how it works in real life, in code. So here it's a quite simple application. It's just a node application. I got 3 libraries. I got event source, JSON patch, and hire drone to pilot the drone. So first of all, we are going to create a drone client. And I'm going to pass options to him because I had to tweak a little bit the configuration of the drone to be able to do that. Okay, once I've got that, I'm gonna create an event source object by calling the new event source with the URL of the API I'm interested in. So I first copy-paste my curl command. I'm a real developer. I'm lazy as much as possible. Okay, so, and now I'm gonna take this API, which gives me the value, and Bitcoin has been sold, so here we are in USD, but we can, pretty sure we get GBP. Great. And the value which interests us here is the last value. So it's the last value a Bitcoin has been sold in British pound. So I'm going to replace the stock market API by this one. I'm going to need a data object and a last object. And here I'm going to create, I'm going to add my callback. So my event listener, sorry. The first one I'm going to create is on the data event. So that's my first snapshot, okay? So the data object will be snapshot.data. I'm just calling my data field. The last object will be data.last, and I'm gonna log so that we can have a view of what's going on. So it will be my first patch. Okay. Okay, so now I can add another event listener to the patch event to see only what has changed. So this function is going to send me patches. Okay. So here I'm going to create another object just to make the code more readable. Oh yeah, sorry, I forgot something. I got to JSON parse this one. Okay, so JSON parse patches.data. And here I'm going to use the JSON patch library to apply the patch to my initial document. So JSON patch.apply on the data object, the patch. Okay, we're going to log. So it's our patch last. And from this point, we can start the comparison. So if the last value I received at first is under the data.last value, it means that the Bitcoin has gone up. So I'm going to log up. And I'm going to ask the drone to go up at a speed of 0.5. If it's not the case, it means that the Bitcoin has gone down. And I'm going to ask the drone to go down too at a speed of 0.5. Then I reassign my last value. Now I'm going to listen to the error event. That could be interesting, you know. So in the case something is going wrong, first of all, I would like the drone to land. I would like to close my event source session, and I'm going to log the error. Okay. And then I I would like the drone to stop after 30 seconds. So I'm going to say after 30 function. It's going to be almost the same, except that I'm going to say console.log time's up. Okay, fine. So first of all, I'm going to check that I didn't screw up with my code. Okay, so I got the first patch. Got my patch last. Okay, so from this point it should be nice. So let's start the drone. So I hope the Bitcoin will not go too much up and up, because the cells will be hurted first. Okay, so we have to wait for it to be ready. Nice. Okay. So I'm gonna share my connection with the drone. Just want to check something. Channel 1 will be better. Okay, start. Now I'm waiting for, okay, that's fine. Okay, great. So, first patch, okay. So, what has gone wrong? Yes, obviously. Options.ip works better. No? Still not? Okay. So I'm just gonna check. No, that's a good one. So you're supposed to fly, especially because you're answering on a telnet. Yep. So that's funny. First time it happens. Yeah, obviously something is missing there. Drone.takeoff. Could be useful. No, not telnet. Here we are. So here we received our first batch. We're waiting for, okay, so up. Down now, please. No, okay. Okay, if you can stop buying Bitcoins. Okay, so up and thumbs up. And here we are. So, I hope I convinced you that server-sent events is a really nice technology. If it's the case, you can vote for its support in Edge, and I will thank you forever for that. And I think we got 2 minutes left if you got questions. If you don't have questions, we can make it fly again. No questions, no one? Okay, do you want another tour of the drone? Oh, yeah, one question? Can you just speak a little bit louder, please? Yeah, but you can use it between two servers. That's absolutely not a problem. For example, in Java, you get server-sent library. You get also JSON patch library, same in Python. So you can definitely use it for a server-to-server connection. Yeah. Yeah, but so for example, in the browser, we have wrote a JavaScript SDK, which has a polyfill included, so you can use it with every front applications. I'm going to make a demo tomorrow where I'm live coding an Ionic application by using the proxy. So it's it works really well with front application. I've also created a Polymer element. If you're making applications with Polymer, it works perfectly. There is no cost. Really, it's very, very simple to integrate. You just have to use your two libraries, the FastJSON patch and the server-sent events libraries, or to use our SDK. And it really works like that. It's really, you've seen I've just live coded it in 2 minutes, something like that. So, okay, yeah, the pricing. So the pricing, it's free from 0 to 1 million messages and 10 connections in parallel. Then it's 10 euros per million messages. And then we got an on-premise version for business customers. That's it. Time's up. Thank you very much.